The size of a surface is called its area. In this video, we are going to quickly revise the area formulae for a few basic shapes. The area of a square is the length of its side squared. The area of a rectangle is the product of its length and its breadth. The area of a parallelogram is the product of its base and its height, where one of its parallel sides is taken as its base and the perpendicular distance between the two parallel sides is its height. The area of a triangle is half the product of the length of its base and height. Note that a triangle is half a parallelogram. Another way of calculating the area of a triangle is using the Heron's formula. It is used when the three sides of the triangle are given. It involves calculation of S, the semi-perimeter of the triangle. S equals half of a plus B plus C, where A, B, and C are the lengths of the three sides. The area is square root of the product of S, S minus A, S minus B, and S minus C. If lengths of two sides of a triangle, and the angle between the sides, are given, the area of the triangle is half of the product of the lengths and sine of the angle. The area of a circle is pi multiplied by the radius squared. Pi is a constant, which is the ratio of circumference to diameter of any circle, and is approximately equal to 22/7. A semicircle is half a circle. Its area therefore is half pi r squared, where r is the radius. A sector of a circle is a portion of a circle with a shape like that of a pizza slice. If theta is the angle between the sides of a sector, the area of the sector is theta by 2 pi times the area of the whole circle. This simplifies to half theta r squared. Segment of a circle is a piece of a circle cut out by a chord of that circle. By joining the endpoints of the chord to the center of the circle, we get a sector that comprises of the segment and a triangle. The area of the segment is area of the sector minus area of the triangle. Substituting with their formulae and simplifying, we get area of the segment to be half of theta minus sine theta multiplied by r squared. An equilateral triangle is a triangle with equal sides. Its three angles are 60 degrees or pi by 3 radians. The perpendicular drawn from one of its vertex to the side opposite to it bisects the side. With these properties, using any of the triangle formulae, we can get the area of an equilateral triangle to be square root of 3/4 times side squared. Quadrilateral is a closed polygon with 4 sides. We can calculate its area by joining two opposite vertices with a diagonal and thereby dividing it into two triangles. The area of the quadrilateral is sum of the area of the triangles, giving us area equal to half of diagonal multiplied by sum of heights. If one pair of opposite sides of a quadrilateral are parallel to each other, it is called a trapezoid or trapezium. By dividing it into two triangles and adding their areas, we can get its area. The area is half of sum of parallel sides multiplied by the height. A kite is a quadrilateral with reflection symmetry across a diagonal, which means the diagonal divides the quadrilateral into two equal triangles. The diagonals of a kite are perpendicular to each other, and the area of the kite is simply half of the product of its diagonals. If all the sides and angles of a polygon are equal, then it is called a regular polygon. Apothem is the perpendicular drawn from its center to one of its sides. The area of the polygon is half the number of sides times the length of its side times the length of the apothem. In a regular polygon, the line joining the center to one of the ends of a side and the apothem corresponding to the side make an angle equal to 180 by n degrees. The area of the regular polygon gets simplified to 1/4 n s squared, divided by tan 180 by n. A rhombus is a parallelogram with equal sides. Its area is side squared multiplied by sine theta, since the diagonal opposite the angle divides the rhombus into two equal triangles, each of area half side squared sine theta. The diagonals of rhombus perpendicularly bisect each other. The rhombus also has symmetry about its diagonal, making it a kite. So, its area is also given by half of product of its diagonals. The area of an ellipse is pi times the product of its major radius and minor radius. The cube has 6 square faces. The surface area of a cube therefore is 6 times side squared. A cuboid has 6 rectangular faces and its surface area is the sum of their areas. It is given by twice the sum of products of length, breadth, and height taken 2 at a time. The curved surface area of a cylinder is its height multiplied by the circumference of its base. If the base radius is given, the curved surface area of a cylinder is 2 pi r h. The curved surface area of an oblique cylinder is its slant height multiplied by the circumference of its base. If the base radius is given, the curved surface area of an oblique cylinder is 2 pi rl. A right circular cone, if cut open along the slant height, forms a sector of radius L and arc length 2 pi r. The angle of the sector, in radians, is the arc length by circumference of the circle, multiplied by 2 pi. We get the area of the sector using its formula and simplifying as pi rl. The curved surface area of the cone is therefore pi rl. The surface area of a sphere of radius r is 4 pi r squared. A hemisphere is half a sphere, so its curved surface area is half of 4 pi r squared, which is 2 pi r squared. A frustum is a part of a cone. Pots and buckets are often in this shape. Its curved surface area is the curved surface area of a cone formed from the larger base minus the curved surface area of the cone formed from the smaller base. Simplifying the expression to include only the given variables, we get pi multiplied by sum of the radii multiplied by the slant height of the frustum. The lateral surface area of a pyramid is sum of areas of its triangular faces. This works out to be half the product of the perimeter and slant height. The lateral surface area of a regular triangular prism is sum of the areas of its rectangular faces, which is 3 times the product of the length and breadth of one rectangular face. In general, for any regular polygonal prism, the lateral surface area is the product of the perimeter of its polygonal base and the length of its rectangular face. The area of an n-pointed regular star is 2n times the area of the triangle formed by joining one of its sides to the center. The angles of the triangle are 360 by 2n, 360 by 4n and 180 minus 360 by 2n minus 360 by 4n. One of its sides is the radius r, simplifying we get the given formula. Hope this video was useful. For more such videos, please subscribe. Enjoy learning and have fun.